Here is an example of calculating the volume using the shell method, in which we're revolving about a horizontal axis which is not the x-axis. So for our problem, we're going to take the area bounded by y equals 2x, y equals 6, and x equals 0, and we're going to revolve it about the line y equals 6. So let's start by labeling our x and y axis and then our line of revolution, or our axis of revolution. So here at y equals 6, we have our axis. And now we want to sketch the bounded area. So we have the equation y equals 2x and we have the line y equals 6, so our axis is also a boundary for our area problem, and x equals 0, or the y-axis. So here is our shaded region, and we're going to take this and we're going to revolve it about the line y equals 6. So now if we sketch our picture of our solid, we end up with this cone shape figure. Okay, next we're going to sketch in one of our cross sections. And we're using the shell method. So our shells will be lying along the y-axis. And our shaded rectangular strip. And now from our cross section, we can identify if this is going to be a dx or dy problem. We will need to identify the radius, and we'll need to identify the height for our cross sections. Okay, so if we start by identifying the thickness of each of our shells, that comes from the thickness of this rectangular strip. And in this case, we are measuring the distance along the y's. So this will be a dy problem, which means our radius will need to be in terms of y and our height will need to be in terms of y. Okay, next we need to figure out what the radius will look like for each of our shells. And our radius, we always want to measure from the axis to the outer edge. And then the height for each of our shells. We'll be measuring from right to left. Okay, remember the radius is the independent variable, and the height will be the dependent variable. Okay, so for our radius, we have to measure from the axis out to the outer edge of our cylindrical shell. So when we do that, you always want to take the larger value minus the smaller value. And this is always in terms of y. So our y values will be as large as 6. And then we'll subtract off whatever value for y that we are inputting into our function. Okay, so our radius will just be 6 minus y. For our height is dependent upon our radius, so this means we need to look at the values or our functions that they actually gave us. So here we're looking at x right minus x left. When we look for our x right function, the x right function is the line, and it needs to be solved for x in terms of y. So x is going to equal 1/2 y. And for our x left function, that's just the y-axis, so that is where x is equal to 0. So our equation for height is just going to be 1/2 y. Okay, so now we have the radius, we have the height, and we have the thickness of each shell. So we can accumulate those by taking the integral of 2 pi times our radius, which was 6 minus y, times the height, 1/2 y, times the thickness of each shell, which is dy, and we're going to accumulate this over all the y values, which start at y equals 0 and goes up to y equals 6. Okay, so there's our setup, and then you'll of course distribute and you'll integrate, and once you evaluate, you should end up with the answer of 36 pi.